Hello everyone. In this lecture, we just want to briefly discuss the graphs of reciprocal of trigonometric functions. So y equals cosecant of x, as you know, it is defined as 1 over sine of x. So cosecant function is the reciprocal of the sine function. And the sine function, cosine function, we have graphed them in the past, but this red graph is the graph of sine of x. Now imagine when you want to find the graph of 1 over sine of x, you have to construct the table of values, and this time you have to divide 1 by the sine of the selected angle. Now let's say you have 30 degrees. Let's say you select 30 degrees. Sine of 30 is 0.5, okay, 1/2. So 1 over 0.5 is going to be 2. So this time, the values that we are getting for cosecant are more than 1 actually. So 2 would be above the max line of 1. So it will be somewhere here, for example, okay, above y equals 1, because 1 over 0.5 is 2. And these are the maximum minimum lines. And similarly, if you consider 90 degrees, 1 over sine of 90 is 1 over 1, which is 1. So that point is common point between the graph of the cosecant, the green one, and the graph of sine x, the red one. And then again, if the value of sine gets smaller and smaller than 1, reciprocal of that smaller number gets larger and larger. So that's why the graph goes up instead of going down. So this way, we are generating all these upward curves whenever the sine cycle is like a semicircle, you know. And then here in this bottom part, because it's negative, so the values of y for cosecant function would be less than -1, and that's why they are below the horizontal line y equals -1. And this is the same because these graphs are periodic graphs. These functions are periodic functions. They keep repeating their same shape over and over their own cycles, which is 2 pi. So because of that, you see that all these curves, upward or downward, opening up or opening down, they keep repeating over and over, just like the sine function was never ending from left side or right side. So this green part you see are the graphs, are representing the graph of cosecant function. But what about these vertical lines? Well, these are the points where sine x was 0, and 1 divided by 0 is undefined clearly. Therefore, wherever we have an x-intercept for the sine function, that is where we are going to have a vertical asymptote for the cosecant function, which is the reciprocal function. So we said that the x-intercept of the sine function are x equals k pi, 1 pi, 2 pi, 3 pi, 4 pi, so on and so forth. Therefore, at all those values, k pi, we are going to have all these vertical asymptotes. So the equation of the vertical asymptotes for a cosecant function is going to be x equals 1 pi, x equals 2 pi, 3 pi, 4 pi, so on and so forth. Generally speaking, x equals k pi, where k is an integer. The range of the function is very clear. It's everything above y or below -y. Before, the graph of sine x, the red one, was fluctuating between 1 and -1. Everything was between 1 and -1. Now everything is outside -1 and 1, including 1, of course. So we're going to say y is greater than or equal to 1, which represents this upper part, and or y is less than or equal to -1, which represents this lower part. Domain of the function, we have no restriction except wherever we have the x-intercepts of the sine function, which are now playing the role of the vertical asymptote. So we have to exclude them from the domain of the function. We can't say that cosecant function is defined at 1 pi or 2 pi, okay? Because at 1 pi and 2 pi, sine function has a value of 0, and 1 over 0 is undefined clearly. There is no x-intercept clearly, okay? There is no y-intercept for cosecant function, and the period is the same as sine x, so that's 2 pi, and there is no amplitude, of course, here either. Reciprocal of the other two functions are similar, like 1 over cos x would be the secant function. So if you want to draw the graph of secant of x, it will be 1 over cos x. So you have to repeat something similar to this, but this time with the green graph, okay? It would get something similar to this with a whole bunch of vertical asymptotes. Obviously, wherever cosine in the denominator is 0, you're going to have vertical asymptotes for the secant function this time. And the reciprocal of tangent is cotangent. So y equals cotangent of x is actually 1 over tangent of x. So wherever you see the graph of tangent has zeros, then 1 over 0, which is cotangent, will be undefined. So here at 0, we should have a vertical asymptote for the cotangent. At pi, we should have another vertical asymptote for the cotangent function. Negative pi here is another x-intercept. So wherever tangent has an x-intercept, that's when we have a vertical asymptote for the cotangent function, which is reciprocal of tangent. So here we're going to have another vertical asymptote. And the equations of vertical asymptote are not going to be odd multiples of pi over 2, as it was the case for tangent function. They're going to be actually whatever the x-intercepts are for the tangent function. That is 0, that is pi, that is 2 pi, 3 pi. So x equals k pi is the general equation of all vertical asymptotes for the cotangent function. Okay? Because the denominator, tan x, is 0 at x equals k pi. So 1 over 0 is undefined. What do you expect? So that's why we end up with a vertical asymptotes there. And the graph is going to look similar to this green graph, the tangent function, except the other way. Whenever it's increasing, this one is decreasing, and vice versa. So here the graph is increasing, but here the graph is decreasing. Okay, and then in this part, the graph of tangent is increasing. The graph of cotangent, because it's the reciprocal, is decreasing. You can also use a table of values method to draw the graphs. But this red graph I'm drawing right now before your eyes is the graph of cotangent of x. That's how it looks like. They're like sort of similar. So this was the vertical asymptote. Yeah, that's right. So it's going to come. Yes, it's going to pass through this point and then goes down just like that. Okay, did I miss anyone here? No, this is okay. Is there any? No. So wherever we have 0, 0, 0, we have the vertical asymptote. And yeah, the graph, yes, the graph is okay. Although I don't have graph paper here, I can't do a very, very meticulous graph, but these graphs are all in the textbook. In any kind of trigonometry book, you check it out. Even on the websites, various websites, you can easily find the graphs of secant function, cosecant function, tangent, cotangent function, and their properties are like a conclusion that you can come up with them by yourselves, or it's also summarized in charts. So just to have an idea, I wanted to give you an idea of how the graphs of these reciprocal functions look like. Okay, thank you for your attention and keep practicing, don't forget.